The diagram below shows quadrilateral OLMN in which O is the origin. Vector OL is equal to 4y, vector OM is equal to 6z, and vector ON is equal to 2x. The point A lies on the line LM such that the ratio of LA to AM is 1 to 2. So what I'm going to do right here is I'm going to write 1 and 2 right there. And the point B lies on the line MN such that the ratio of MB to BN is 2 to 1. So I'm going to write 2 right here and 1 right here. Now the question says, let's move to the question. It says express in its simplest form vector mn in terms of x and z. Now vector mn means we are starting at m and we are ending at n. Therefore, we need to find an alternative path in the form of a triangle to end at n. Right? So therefore, the alternative path would be MO and then O to N. So if we add those two, we get the vector MN. Now MO is negative 6z. We are moving opposite to OM. So negative 6z. And ON is 2x. So plus 2x. Normally, we prefer to write with plus 1 in front. So this is 2x minus 6z. So let's look at the next question. Now, 2a says, find in terms of x and y in its simplest form an expression for vector Ln. Now, again, we are starting at L and we are ending at N. So we need to find an alternative path in the form of a triangle to end at N. We want to find the vector Ln. Now, we are going to find the path of a triangle that will enable us to start at L and end at N. Now, this is going to be LO, vector LO plus vector ON. Right? Now, vector LO is negative 4y because we're going opposite to vector OL. So this is negative 4y. And vector ON is 2x. Again, we tend to write the positive first. So this is going to be 2x minus 4y. Now, the next part you could move is LM and then MN. Now, we tend to take the path that they give us information for. If you chose LM, we haven't been given any information for vector LM and we haven't been given any information for vector MN. So we don't want to choose those paths, right? Even though it's a valid triangle we could move in, we have no information of the vectors, right? Now, let's look at part B. Part B says, show that vector AB equals 2/3 2x minus 4y. So let's look for vector AB. So vector AB is here. So that's vector AB. And we're going to look for the triangle so we can take to get start at A and end at B. So look for the triangle. So the triangle is going to be, so vector AB, AM, because we're starting at A. So that's vector AM, and then plus vector MB. Right? Now, vector AM. Vector AM, we're going to use the ratios now that they gave us. So vector AM is going to be, now vector AM is 2/3 of the line LM, or if we want to put this as a vector, we could. And vector MB is 2/3 of the line MN. Right? We put it in a vector. Now the line LM, we need to express that line in the form of X and Y. Now, what is the vector LM? Now, if we move in the path of a triangle again, the vector LM is going to be, let's write back our 2/3. So 2/3 LM, moving in the path of a triangle starting at L and ending at M, we're going to get 6Z minus 4Y. And what is the vector MN? We're going to do the same triangular method. So vector MN is going to be 2x minus 6z. Now, if we expand the brackets, let's use a different color. We're going to get 2/3 6z minus 2/3 4y plus 2/3 2x minus 2/3 6z. Now notice that we have what we have here. We have 2/3 6z and we have negative 2/3 6z. So those will cancel. Let's write the positive 2/3 2x first. Let's write the positive 2/3 2x first. This one. So this is going to be 2/3 of 2x minus what we have left. 2/3 of 4y. Now 2/3 is common to both of these terms. So therefore I can factor it out. 2/3, and I'm going to be left with 2x minus 4y. So I've shown that vector AB is 2/3 2x minus 4y. So the next part of the question 3, based on your results in part 2, state 2 geometric properties relating Ln to AB. We have shown that vector Ln, here it is 2x minus 4y, and we also show that vector AB is 2/3 2x minus 4y. What this is saying is that we can express one vector in terms of the other. Because let's look right here. 2x minus 4y is vector Ln. So therefore I can write vector AB is equal to 2/3 of vector Ln. That is, vector AB is a multiple of vector Ln. When this is the case, when you can express one vector in terms of another vector, they are said to be parallel. So we can say that vector AB and vector Ln are parallel. Again, let me reiterate. Once you can express one vector in terms of the other, they are parallel. Right? Now let's move on. Here it says, determine the values of the unknowns in each of the matrix equations below. Right? So here, we need to find what is the unknown. One unknown is x and one unknown is y. Let us add corresponding elements. Now, the x is the first term, so therefore we're going to add it to the first term 4 right here, and then we're going to equate it to negative 3. So this is going to be 4 plus x is equal to negative 3, right? That means x is equal to negative 7. Similarly, y correspond to the 8 right here and also the 2 right here. So we have to say negative 2